Have you ever wondered where your food comes from? Welcome to At the Farms, brought to you by FarmAnywhere. In this series, we take you on a journey to explore the incredible diversity of farms that produce the food that we eat every day. Big and small, traditional and modern, we'll be showing you how they work in growing the food of tomorrow. I'm your host, Gabriel Zerfanitis. In today's episode, we're taking you to a vertical farm just 15 minutes from downtown Calgary, Canada. Deepwater Farms is a hydroponic farm run by an innovative team finding creative solutions to supply Calgary with hyperlocal, fresh leafy greens. Stay tuned to find out how they operate this modern farm. Welcome to another episode. We are here with Paul from Deepwater Farms in Calgary, Alberta. Paul, you're the legendary inventor behind this facility here, the designer. What would you say is the most differential thing from this compared to what we see on the internet all the time for vertical farm?
I would say that we are very farmer tech. We're not high tech, we're simple, we try to keep things straightforward and fundamentally understand the potential of controlled environment agriculture in our region.
I'll let you give us a tour as to where you want to start.
Yeah, let's go. We'll start with the seeding. So we are in a subsection of our farm where we do all of our seeding. It's also where we keep all of our inputs and inventory and everything like that. It's a bit of a multi-use area right now, so Eric, one of our lead horticulture technicians, is using this space to prep some trays for herb seeding. But typically, when we're seeding our main crops of baby greens, it all starts with a transplant tray, an EPS tray, typically used to move your seedlings out into bigger grow-out trays. But these trays were convenient enough for us that it's the right density for us to grow the baby green varieties that we grow. And so we're using a Visser seeding line from the Netherlands. We load our trays in the back, we put our media in the hopper, and we can continuously seed these trays with just 1 to 2 operators. So this machine saves us a whole ton of time. And this is where our process starts.
Yeah, and one thing that's quite different between this facility and other vertical farm facilities is that you use the same technique as greenhouses where you float your rafts onto a deep water culture tray that we're going to see a little later on. And then basically the plant stays in those trays throughout the cycle as they go from one side to the other of the facility. So that's why you're using this solution as well.
Exactly.
And it seems like you're using some sort of substrate. We're used to seeing rock wool or inert kind of substrate inside of vertical farm. You decided to go with cocoa peat moss kind of mix. You want to explain more?
Absolutely. So we're using straight cocoa core. Okay. We're not using any peat moss right now. What we are doing is soaking the bricks. We are charging the bricks just to balance the EC and the pH and adding a few different types of nutrients so that it's very stable by the time it enters into the system, because we did find that it was absorbing nutrients out of the water and giving us issues with our nutrient recipe. Okay. And then all we're doing is simply adding some perlite to give that porosity that it needs to allow transpiration through the roots and everything. Yeah.
Amazing, yeah, really good. And that's, I guess, the cost compared to rock wool. How does that differ? Do you have any idea on the cost input?
I mean, cocoa core was the most cost-effective method for us to use. It's also more environmentally friendly as well. And so for us, a big part of it is at the volume we're producing at, we have a lot of this waste at the end of our process and we have to do something with it. And so rock wool was really hard to compost, recycle, expensive to throw out. And so with the cocoa core, it's a really good value add to compost. And so we're able to put this into tote bags and we have a tree farm that picks it up. And so, it solved a couple problems for us of what do we do after? Because it's expensive to get it disposed of to a landfill versus having somebody come and pick it up for free. And with that in mind, it's something that we might be able to turn into a product of our own down the road.
Amazing. Reusability in mind, from your trays to your inputs on that side. Great work. One thing that Deepwater Farms does a bit differently too is the way that their nursery is set up and how the seedlings are sprouted. Let's go have a look at that setup right away. What do you think?
Yeah, sure.
Yeah? All right. So as you know, square footage when it comes to vertical farming is a big cost when it comes to input, and therefore having rooms dedicated to nursery can become quite expensive if you make the difference between your profit and loss table. At Deepwater, you guys do things really differently. Walk us through this setup right that we see right here, and what was the thinking behind that, and how'd you got about doing this?
Yeah, so coming from the seeding area, the plants obviously need to germinate, and so given that this room is already pretty warm, pretty humid, pretty good parameters to germinate in. And so all we simply do is we take the trays after they've come off the seeder and we stack them on a pallet and we just wrap them with a plastic wrap to contain that moisture. How we came up with this was actually a bit of a happy little accident. While we were building out this facility and getting everything ramped up, we were in another space and we would just bring these over on our truck. So we had to palletize them, wrap them up, transport them over. And by the time they'd get here and ready to go into the system, they were germinated and ready to go. So we just continued on with that method and it's been working out really well.
Yeah, and then from there, they go straight into your tray right here.
Exactly.
I want to bring up another thing too. It's already warm, it's already humid. Deepwater Farms has a different kind of HVAC system that you've probably never really seen before, but we'll talk about that a little later on. So while we're here as well, we see your fertigation totes here. Walk me through your recirculation process and dosing and all that. How do you go about doing that?
Yeah, so again, we've kept things really simple. We have an A-B solution as well as a pH adjustment. And so in Calgary, we have very basic water. So we need to add some acid to bring that pH level down. Otherwise, we're using a standard auto grow system. All we're monitoring is EC, pH, and adjusting that with some peristaltic pumps based on the recipe we've set. We monitor our dissolved oxygen. Yeah. We monitor our ORP so that we can adjust for sanitation protocol. Outside of that, the water parameters are taken with a bi-weekly water sample that we bring to a lab to get an analysis and a breakdown of all the macro and micro elements, because we do see drift in the different elements that we're trying to control for, and it really matters when you're trying to fine-tune a recipe for arugula or your brassicas and things like that. So that's basically how we manage our water quality right now.
Awesome. So in these totes, you only have the fertilizer and then those are injected into the system?
Yeah. Into
the trays directly, or you have like a mixing tank along the way?
Yeah, so our system is, basically a modified deep water culture system, and all the water circulates through the beds to a drain that leads to a sump tank under the ground, which is where we're pumping the water out of and back into the grow beds. And so as the water's getting pumped out of the sump, we're testing it for EC and pH, and then through our auto grow system, it's telling it to dose. And so through the peristaltic pumps, it's just dropping in that nutrient solution and the acid for adjustment. Okay. And so it's constantly recirculating and testing.
Okay, amazing. And then do you have a water chiller as well? Because your volume of water is quite substantial in this system. You know how many liters you have about, more or less?
80,000 liters in total.
So substantial amount of volume. Yeah. And then, so water chilling this, or they're just additives?
No water chilling.
Perfect. Yeah.
So I think that kind of goes back to like how we started, and also what's allowed us to stay in business. Because we've seen a lot of these bigger companies with hundreds of millions or tens of millions of dollars in funding go bankrupt.
For sure.
And we've always taken the method of let's build to need as we go, not build what we think we need and over-engineer, over-design, yeah, and now costs get out of control. Yeah. And as a farmer, when things are working, you don't want to change it. But when we started at, the base, you're starting with like the minimum viable product and then always adjusting up based on exactly what you need. Yeah. And so we found that like, in theory, yeah, we should be running this water for maybe 5 degrees colder than it is right now, but we're still achieving incredible yields. And so I think for us, it's kind of like understanding what the principles are, but not being afraid to go into a different direction. And I think, yeah, we've been told we need a water chiller, but we're running fine and we're doing, hitting our yields. And I think same with like the HVAC system. When we started, it was the cannabis boom and everybody wanted to sell us $1 million HVAC system. Yeah, exactly. And we kind of just went against that trend and, we said, well, we'll add it when we need it. And we've been able to run this farm to our expectation.
Yeah, amazing, amazing. So every single piece of equipment that you add is not just the cost of that equipment. you got to keep in mind, you got to maintain that equipment. You got to get replacement parts. You got to have someone that checks on it and does regular standard operating procedures to make sure that equipment stays online. And that when you remove those pieces, of course, you're saving the CapEx, the original CapEx from the get-go, but you're also saving all of that labor and all of that time maintaining that piece of equipment that at the end of the day, you may not even need. And that's a good way to make sure that you're staying in business when it comes to low margins that we have to deal with in this field as well.
I would build on that too, though, is that we also went into it with an understanding of our natural environment in Calgary. And so what happens in a vertical farm? You get a lot of heat, you get a lot of humidity. Being in Calgary, we have cool, dry air. And so we went into it saying, let's just do big volume air turnovers and control the climate that way. And it's been working. And so the plant still needs CO2, but using just a simple greenhouse burner that just burns the natural gas, we can keep our CO2 levels, between 600, 800, and 1,000 ppm, depending on the time of the year, which is sufficient enough for us to grow a high yielding crop. And so, we looked at that as like a biomimicry thing. It was like, hey, let's take that cool, dry air and bring it into the farm and kick off that other stuff. And that works 80% of the time in Calgary. So amazing. That significant investment to control the environment precisely for 20% of the year just didn't have an ROI.
Amazing. Well, let's go into the main grow operation now with the racking system. All right, so we're in the grow area where all the plants are set on this side, right? And then they get moved towards the back end of the farm. Walk us through your design system with your racking, how you came about doing this design there.
Sure. So when we started, there was no off-the-shelf vertical farming technology. We built this facility in 2018. The only thing you could really get was lights, LEDs. And so we wanted to build a system as a novice grower who has no experience. What's a very robust, simple system, and Deepwater culture just kept coming up and kept coming up. And so we knew that we wanted to do multi-layer indoors with LEDs. And so we set out to design a Deepwater culture system, but we wanted it to be a continuous system. So meaning that we could run it like a manufacturing operation, because everything that we were seeing were these types of pallet racks, but they're just accessing it from this wide end. And so you can only really get like an 8-foot or a 12-foot continuous section. We wanted to go in one end and out the other. And so the Deepwater culture also allows us to have our EPS trays, which float on the water. So you can push from one end and the whole thing moves. And that's what you see in a typical greenhouse. So we just kind of mimic that so that we could operate this with as little labor as possible, meaning that one person can be here with the germinated trays, push them in, and that harvest-ready product pops out the other end. And that also makes sure that we don't have any downtime in our beds or the lights, so that we can run the crops very consistently, which is a big factor when it comes to harvesting it, packaging it, and getting it out to customers.
Yeah, one thing you see sometimes in facilities where every single square inch of your light, if it's not used by a plant, then it's wasted energy, it's wasted power for no reason. So by doing it in this way, where as it gets pushed, there's the seedlings coming in, these lights can stay on, and basically throughout the whole cycle, you always have light touching. So that power that you're paying for is always being used to output vegetables, output actual weight,
And we can dim these lights as well. So when we put these, new seedlings in, as soon as the harvested crop's out, we'll dim those lights down to give the seedlings the DLI that they need versus the full DLI that these bigger plants want.
So do you do that automatically, or you have a PPFD meter? What's your process for dimming down? Just experience?
We just have an external dimmer, so that we can control it, and we know the PPFD of those lights at that dimming range.
Yeah, amazing, cool. And then so this was born out of necessity because you wanted to do this. What was your style when you started designing a system with pallet racking and all that? What was your thought process when you put it together?
It was very iterative. So we didn't just go and build this whole farm. We started with a 20-foot section of pallet racking compared to the 60-foot section. Okay. We started with just 2 simple beds, tested all of our assumptions on it, made sure that we hit the yield that we knew we would need to hit in order to be viable. Yeah. And so once we had that, then we started to build out this farm. And so this is like, the third or fourth iteration already of designing the bed, designing the plumbing, and understanding the flow of the crops in and out of the system to minimize the labor, make sure the flow rates are right, and just all those details. But again, it's a pretty simple process.
Yeah. So start small, learn, move fast, and iterate.
I mean, we like to say build, measure, learn, and repeat.
Build, measure, learn. I like it. All right, let's make it to the harvesting area, and we'll talk about the HVAC also there.
Sure.
All right, Paul, so we're at the back of the tray system, and these crops are about to be harvested. Walk us through a little bit of the process for taking them out and bringing them into your harvesting machine there.
Yeah, for sure. So all of our crops are on a 14-day cycle, meaning if today's Monday, in 2 weeks Monday, we're gonna harvest that same crop from the same location. And we have everything lined up so that we can harvest a full rack at one time, allowing us to position the harvester and all of our harvest equipment right in front of it to minimize the amount of steps between plants to harvester and then into the fridge.
Okay.
And so we have a method, a ramp system that gets inserted into the beds. And so once the person at the back end is pushing and inserting the new germinated trays, these harvest ready trays come out, and then they'll get transported to our harvester, which will be positioned, nicely right in front of the rack. And so we can put the plants on one end, push them through, they'll get cut and then inserted into a bin, and then that bin will get stacked on a pallet with all the other bins from that grow bed, and then brought into the fridge that day.
Super efficient, and we've seen it done. It looks a little bit like a party in here. There's music going. It's teamwork from one side to the other, pushing it all out. Looks really, really fun to work in the environment as well. Sometimes farm work is difficult and it's not fun. It could be like, hot, humid, but when you have a team and you're doing tasks that are important to you and important to the community, as well as important with the people that you're working with, it makes all the difference inside the
Absolutely.
facility.
Yeah.
And obviously Deepwater Farms doesn't use any chemicals, doesn't use any pesticides or herbicides and all that. They have a intriguing IPM strategy. Let's talk about it a little bit more here with this plant right here that I thought at first it was filtration for the water, but it looks like it's something completely different.
Yeah, so we have we're controlling for a few different things. We're controlling for aphids, thrips, moths, and then I guess you can call it like bacteria and fungus. And so what we're looking at here is simply like oats. So we seed the oats start coming, and then there's a certain aphid that will only want to hang out in these oats. It doesn't like any of our other crops. And so what those aphids on the oat grass become is a food source for beneficial wasps. And so don't think like a big buzzing around wasp. They're a tiny little wasp that will lay their eggs in those aphids so that we can have a sustained population of the wasps that will go and eat the other aphids that we don't want in our other crops if they're there. So typically we don't have a lot of aphids because those wasps are so efficient at going and finding them. And then the other things that we're controlling for is thrips. Okay. And so we're just buying a standard off-the-shelf package of mites, and they just come in little sachets that we'll strategically place around the farm, and they just kind of go out and they do their work, they manage the thrips. The other problems that we've experienced is diamondback moths. Okay. And what they'll do is they're a tiny little moth that will lay eggs, caterpillars come out, and those caterpillars will decimate a crop. Okay. And it's one of those exponential things. You see a little damage, the next week you see a little more, the third week your whole crop's gone. Yeah. And so we came up with a very unique solution for that. Okay. Moths love light. So what we'll do is we'll turn off all the lights, set up bug zappers around the farm, and we do that about twice a day, especially in the summertime and the spring when those moths are out. And a moth to the light, the analogy is so true because we turn the lights off, the moths leave the bed, go to the bug zappers. We've now completely disrupted their life cycle. Yeah. And I mean, that was just the solution because we wanted to maintain that chemical, herbicide, pesticide-free product. And that was an organic method that was just so common sense we couldn't believe it.
Amazing.
And then beyond that, we're treating for Pythium and other potential bacteria in the water with a simple hydrogen peroxide. and a daily addition of that.
Tried and true, yeah, for sure.
Yeah.
So inside any vertical farms, every single input counts, and you don't want to say, oh, well, it's just a few pennies here and there. It doesn't really matter when it comes to like bringing in beneficial bacteria and things along those lines. So by having an innovative method to maintain beneficial bacteria population inside, this will translate into higher profit margins. And thinking outside the box is super important to be able to make a good profit inside your farm, for sure. Yeah. And also closing the lights. So talking about closing the lights, while we were talking earlier, the lights closed, the lights on the back trees here closed, and then you have a different kind of HVAC system that we don't see too often there. A lot of people think that if you close your lights, you can't have any humans, you can't have any other lights in the farm, and that's just not true. You can still get your DLI even with your lights being closed down during the day. And so you close the lights during the day for what reason exactly?
Yeah, so we're talking right now, July 31st. It's about 30 degrees Celsius outside, and it's the hottest part of the day. And so we simply will just turn the lights off. And all the heat in this room is 99% coming from the lights and the drivers. And so by turning those lights off, we can bring our temperature down, which, is good for the team who's, working hard, sweating. It's uncomfortable to work in that amount of heat. But also, with our lights, we can achieve our DLI in 16 to 18 hours, which is sufficient for these crops. So turning those lights off in the middle of the day is totally fine.
Yeah.
And so that's just part of our strategy to make our climate more manageable to work in. But yeah, our HVAC system is less HVAC, more HV, heating and ventilation. We're not doing any air conditioning.
Yeah.
All we are doing is turning the air over. We have barn fans blowing air in on one end and blowing air out on the other. And we can keep our temperature in the farm on that higher end of the parameter that you want to be on, but we're still within a range.
Yeah. And anyways, with the humidity that you maintain as well inside the farm, you still get the proper VPD for the plants.
Yeah.
So even if you're at a higher range, it doesn't really matter. And then therefore you save yourself quite a big bill, electrical with no AC, but also on the install side too. Did you get any quotes to get an AC in here? Like what was that look?
Yeah.
What does that look like?
It was pushing $1 million.
$1 million.
Yeah.
Yeah. So that's CapEx that would be extremely difficult to give back to shareholders if ever you did spend that $1 million, and that just stayed in the bank account, gives you more cash flow.
And I think whenever I've looked at it, your electricity bill for your lights is typically pretty close to your utility bill for your AC. So our lighting bill is one of our biggest line items, and if we had to double that with AC, it just wouldn't work.
Obviously, you have to be in your own climate. When it comes to that, Calgary, Alberta, Canada is conducive to that.
You have to do what works for you in your zone.
Yeah, exactly. And then in winter, it's the opposite, right? You'll run your light longer and you dim them to get the same DLI and get free heating. Like, what's your strategy?
Yeah, again, we just optimize the output of the light and the intensity for the DLI for the plants, and then we can actually just run the lights longer at a less intensity, which we haven't seen any bad effects on the plants. And again, we just heat the building using some natural gas heaters and some radiant heaters, and
get free CO2 from it.
And you can capture that CO2 off it with CO2 burners. That's how they work. And so it's a pretty simple and effective method for us to hit those.
Cool. All right. Well, thanks, Paul. Thanks for the tour.
Absolutely.
Yeah. Great facility. Good example. Just keep it simple and start from there and then build up your operation. And as you can see, you get an amazing operation like we've seen right here.
Absolutely.
Amazing work. Yeah.
Awesome. Thank you for your time.
All right, cool. So this episode was brought to you by the team at FarmAnywhere. Of course, we build container farms, but we're big components of anything indoor ag and agriculture in general. As you know, there's no such thing as one size fits all when it comes to ag, and we want to showcase all the different possibilities when it comes to that. If you like this episode, like the video, subscribe to our channel, as we're going to do more facility tours in traditional agriculture as well too, coming up very soon. And also go follow Deepwater Farms on Instagram to see what else they have in store. We'll see you on the next one.